Yes, you're welcome to our new lesson. Thank you for using QuestLift. Thank you for viewing our videos. In this topic today, we want to look at physical chemistry, and the topic is thermochemistry. Now, thermochemistry, just as you hear the word thermo, derived from the word heat, we are going to be looking at the heat changes that occur during a chemical reaction. Now, in most or in all reactions, normally heat is given out. And this heat given out, or heat that is absorbed, is very important in our daily life. For example, if we look at the reactions that occur in the body, reactions of metabolism like respiration, the heat that is given out during this reaction is used to derive other reactions in the body. This heat is used as to heat up the body for our warmth. So the heat changes that occur during reactions can be used to do many things. So our understanding what happens during chemical reaction in terms of heat changes offers us knowledge about how we can transform energy from chemical reactions into other forms of energy, because normally energy is neither destroyed nor created, but can be transformed from one form to another. You find that the energy given out during chemical reaction could be used as a source of light, could be used as a source of energy to drive many other things. And so we shall be trying to understand what really takes place during these chemical reactions in terms of energy. So we are going to be saying that thermochemistry is concerned with energy changes that occur during chemical reactions. Energy changes that occur during chemical reactions. And in this introduction, we shall be looking at mainly the terms that we shall be finding in the study of thermochemistry. And some of the terms that we shall find number one, we are saying terms used. Number one, the term enthalpy. This term is going to be used several times, and enthalpy simply refers to the heat content. The heat content possessed, or we can say heat content of the products or reactants. Of course, when a reaction is going to take place, we shall begin by the reactants. The reactants we have before the reaction starts have a certain amount of heat they possess. They have a certain amount of potential energy in them. And when the reaction takes place, the products formed will also have a certain heat content in them. So the term enthalpy is used to talk about the heat content of either in the products or in the reactants. And it is denoted by the symbol capital H. It is denoted by the symbol capital H. So every time we see capital H in this topic, then we are looking at what we call enthalpy. Enthalpy is the heat content of the products or reactants. Now, during a chemical reaction, since the reactants we start with have a certain heat content, and the products that we form have another heat content, there is always a heat change that occurs. There is always a change in the heat content of the products and the reactants. So we normally talk about term number 2, and that term number 2 is called the enthalpy change. Term number 2 is called the enthalpy change. Enthalpy change therefore refers to this is the difference between the heat content, which we are calling enthalpy, to the heat content of the products and heat content of reactants. The difference between the heat content of the products and heat content of the reactants. What are we saying? That the difference, the subtraction that is there, because the products are at a different heat content, reactants are also at a different heat content. So the difference between the two is what we call the enthalpy change, and it is denoted by the symbol delta H, and we shall be saying that delta H will equal to the heat content of the products subtract heat content of the reactants. Heat content of products subtract heat content of the reactants. So the difference is what we call the enthalpy change. Now, the enthalpy change, the H, may be negative or positive, depending on heat content of products and reactants. So the value of the enthalpy change may be negative or the value may be positive, depending on which one of the two is greater. So if the heat content of the products, if the heat content of the products is greater than heat content of the reactants, then the H will be positive. If I can symbolize this, I'm saying if H products is greater than H reactants, then the H is going to be negative. If the heat content of the products is greater than the heat content of the reactant, then the H will be positive, like that. However, if the heat content of the products is less than the heat content of the reactants, if the heat content of the products, this one, is less than this, then dH is going to be a negative. Now, if the overall enthalpy of the reaction is positive, it simply means that the products formed are at a higher energy level or at a higher energy content than the reactants. But if the heat of the whole reaction, the enthalpy change, is negative, then the products formed are at a lower energy level or have a lower energy content than the reactions. Now, there are certain terms that we use to denote such reactions. If the overall enthalpy of the reaction is negative, if the H is negative, it is negative when the heat content of the products is lower than the heat content of the reactants. The reaction is said to be exothermic. It occurs while giving out heat to the surrounding. The meaning of the word exo. So that means there is loss of heat to the surrounding. So you feel the surrounding getting warmer when this reaction is taking place because the heat is being given out, and the result is the heat content of the products that is formed will be less than the heat content of the reactants. But if the H is positive, then the reaction is endothermic. Then the reaction is endothermic, meaning that there is absorption of heat from the surrounding. The products formed are at a higher energy content than the reactants. So you feel the surrounding becomes colder. If I was making a solution and I feel the container becoming colder, then the reaction taking place is endothermic. Heat is being absorbed from the surrounding. So these terms are also used. Now, term number 3, we shall have what we call exothermic reactions. That these are reactions in which heat is given out, to the surrounding. Heat is given out to the surrounding, while the endothermic reactions heat is absorbed from the surrounding. In this case of the exothermic is where we are saying the enthalpy change is going to be negative. The heat content of the reactant is higher than the heat content of the products. When it comes to endothermic, heat is absorbed from the surrounding, and therefore the surrounding becomes colder, and heat content of the products is greater than the heat content of the reaction. Now, these two terms can be illustrated on what we call a reaction profile. A diagram showing the changes in potential energy during the reaction for exothermic and endothermic reactions are called reaction profiles or diagrams showing the reaction profile. So we can represent a diagram, potential energy diagram, potential energy diagram for exothermic reactions. This is energy. Energy can be measured in joules per mole or kilojoules per mole, and this is what we are calling reaction pathway. That if we began with the reactants, if this reaction is exothermic, we are saying the energy content of the reactants, if these are our reactants, and this is energy axis, the reactional gas, and there is formation of what we call an activated complex, or sometimes called a transition state, and the products formed are at a lower energy level than the reactants. This is the products. Now, the difference between the heat content of the products and the heat content of the reactants, dH, is a negative value. Now, the energy required to form the activated complex, the energy required to form the activated complex is what we call the activation energy. And this is a reaction pathway diagram, a diagram showing the changes in potential energy for an exothermic reaction. And we could have a similar diagram for endothermic reactions. So in the next lesson, we shall be looking at the diagram for endothermic reaction. Potential energy diagram versus reaction pathway for reactions that are endothermic. The ones we are saying the heat content in this reaction, the heat content of the products is higher than the heat content of the reactants. Please don't miss the next lesson. Thank you.